Okay. Thanks. So, yeah, Teemu Sipilä from National Land Survey of Finland, and talking about our solution for building OGC API feature services, and also covering some of our use cases and how we are transitioning from old VFS services to OGC API. But first, our organization maintains multiple registers: cadastral, title and mortgage register for housing shares, and other registers too. And also we have a lot of open data and traditional GIS data from topographic database and raster maps, aerial photos, and so on. But I move to APIs then. First, I have some categorization of APIs we provide. There's categorization about API access types, or how they are offered to different customer segments. They are open data APIs with free and API key access. Then they are contract-based APIs for open and licensed data, and also private APIs. All these are provided with same software stack, but for different channels. Then other side, API client technology, it also affects how our APIs are, how interoperably they really are. For example, web and mobile apps for generic user clients, they can easily consume REST or Open API type of APIs, but they have to manage geospatial thing somehow. Then if there's web and mobile apps that are geospatial based, they depend on some JavaScript or other library that it has to have compatibility for some standard. And GIS desktop clients are slowly adapting new OGC standards. And the last section here is if we have also many kinds of data exchange or integration providers that can go to the clients with just coding connectors, but so if they are relying to geospatial servers, those tools should also adopt those standards first. Our current standard stack is presented here. There are web map services and tiled services, coverages, also some processes, but I'm not talking about them. I'm focusing now to feature services, and now we are moving from the traditional web feature service standards to OGC API features. And how we got there, about five years ago, we were building WFS APIs with GML data types. There were some difficulties to build these services, application schemas were quite complex. Then there are different tools to handle, and it was difficult to implement very fast and efficient services. And even if these traditional OGC standards are well known in GIS space, they are not so easy outside GIS space. So we were quite excited when WFS3 was announced about 5 years ago, and that then matured to OGC API feature standard. And our solution for OGC API is our own software component that is called Hakunapi. We started it when the new standards came available as a draft standard. We started development already then. There were not so many solutions available at that time, so we ended up to build our own solution. That was built to support our geospatial data and API architecture, but also there were some key principles on developing and designing these solutions. We had to have simple feature application schemas provided easily with configuration, but then we have also those quite difficult and complex application schemas, so such schemas need more custom code, but this solution tried to make it possible too. And also efficient data streaming was one of the key principles. Streaming features fast and support paging and easily to scale servers. So there are some properties of this feature server called Hakunapi. For data store, there is only PostGIS data store fully supported, and for output, the main output is GeoJSON, but also HTML for web browsing is supported, and also GeoPackage and some other formats has been also tested but not fully supported. Then there is some samples. This sample is provided on the GitHub repository of this Hakunapi package. It's just addresses from open data dataset that is freely available, and this demo service follows GeoJSON encoding rules for Inspire addresses. But here's HTML web view and then GeoJSON output. But then, as I already said, all application schemas are not simple. Here's some cadastral data. This data model is in Finnish, so I don't go in details, but still we can implement OGC API Features service providing JSON output. And another sample, geographic names. Here it's quite simple data set, but there are simple feature data models and also some more complex features or feature types. And for this service, there's on the right side describe on the bottom what steps is needed to implement a service based on this component. So you have to have some Java code for configuration, entity classes, handle some queries, collection classes to database queries, and some modifications to output writers through. So some code was needed on this service outside just not just configuration. There is GeoJSON and TML output from place names. Other is in VGS 84 coordinate, and on the right it is some Finnish map projection. Then a simplified architecture layout of our services for OGC API Features. And on this picture there are also other tools. GeoServer is used for map visualizations on server. Map server is used for raster data, and MapCache for tiling, but I'm not talking about them, so I'm now concentrating to feature services only. There are different databases on the bottom, and then there is some service layer based on this Hakunapi tool. They are both simple feature services that are implemented just by configuration from database schema to feature schema. So those services do not need any Java code. But then there are those more difficult application schemas that, as I already said, need also custom Java code. So those were the use cases that are with bold text. Then there are some other use cases that we have been using this component, but they are more specific to our infrastructure, so they are not so generic. But those bolded use cases can be implemented using the component we have been open sourced. Okay, so then some challenges when building feature services based on OGC, new OGC API standards. The first Client support is still growing slowly. There are clients that support these services, but then there are clients and some clients are giving us feedback that why we are moving to OGC API. But that's the direction we are moving. Then standard development is, there are new ways. The standard is implemented and can be followed on GitHub, but maybe it's still a bit moving target after 5 years of standardization, but it certainly get completed. And those complex application schemas, they are difficult in older feature services, but they are difficult also on new OGC API services. And also alternative coordinate system other than PGS 84 need some care or how to implement and how to provide them and how to be sure that clients can use those other coordinate system we provide on our services, as they are also. But then there's the standard part 2 has some mechanism to announce also information or metadata about what is the coordinate system and what is the axis order on those coordinates. So it is possible to publish with alternative coordinate system 2. Then some pros and cons about this solution. So complex features are supported, but at the same time it needs a lot of custom Java code to implement them. Simple feature application schemas are more easily implemented with off-the-shelf component solution just by configuration. And this is validated with OGC test suite. The component is a framework. It can be extended to different use cases. Java code is quite good with quite good modularity, and it should be quite efficient. But then other cons, this solution is currently focusing only on features, and if implementing extensions based on this solution, the solutions are often enterprise architecture specific. No packages is yet published on Maven Central, which is planned, and this solution is currently used only by us. So, conclusions. OGC API features based on GeoJSON is applicable for simple schemas and with some caveats only for complex application schemas. Then secondly, GIS client support for these new standards is still evolving, and our solution is Hakunapi, which is Java-based for OGC API features and with PostGIS support. Code is available in GitHub, and some planned issues for next steps. This GitHub repository needs some more documentation, and secondly we look for new JSON FK standard, maybe hope to support at least core conformant class of it, and the OGC API Features part 3, which is still draft standard, may also need some implementation on this Hakunapi solutions when the standard is approved. Yeah, thank you.